Okay, guys, let's start the second lecture. I think my voice is fine. So, there were some questions about slicing part, so I thought that it would be better if I start the second lecture with the Cura. This is a popular computed manufacturing software for fused deposition modeling or the popular desktop 3D printer software. And while using it, if you have questions, you can again write it into chat area. Let me open it. Yes, this is our model, an available model. There are different websites. We'll talk about it later. You don't need to sometimes design the part from scratch. You can download it from such sharing platforms like Thingiverse, Imagine, Cast3D. There are many of them. While if you have something in mind for printing, it's better you check it first and then download and print. But otherwise, if you have a specific design, then you need to design yourself and create an STL file. This is the imported STL file, by the way. And here you see the dimensions of it. The height is 107 millimeters, as you see, about 10 centimeters. We simply import it into this 3D printer. This is my printer in the lab. I'll make it 3 extended. And what I do, I import the STL file. I download it earlier, and then I select the type of material. Since this printer has 2 different materials, I select the first one. I will be using the red one, and there are different parameters. For instance, you can do some scaling. Since this one, as you see, will take about 11 hours, since I want to do it in a shorter time, I want to decrease the size, I will do a uniform scaling, let's say 50%. So it will be much less than 11 hours. As you see, this time is just 2 hours and about 20 minutes. Since the volume is also decreased, if you decrease the height by 2, then the volume will be decreased by 8. So that's why we have a huge decrease in the manufacturing time. You can also do some non-uniform scaling, then you may have some weird shapes. Let's do it. Yes, but as you see, the shape will be modified, and mostly we don't want to have such non-uniform scaling. You can do, this is actually, as I said, this is a computer manufacturing software, and here you modify the parameters, the orientation of the part. You may print it in such a configuration. It's up to you. You do all these selections here. Even though it's weird, you can print it like this. You can have 2 of them, 3 of them. There are many issues. And the other ones are here. As you see, there are many parameters, and some of the parameters are hidden. But if you're an expert, you can have more parameters by going into settings and have more, let's say, freedom in the printing process. The most important parameter is the layer thickness. Here you see the layer thickness right now is 0.200 micrometers. If I, let's say, make it 0.1, now you'll see that it will perform the slicing once again, slicing the bunny. Now, as you see, it will take about this twice time according to the previous version. Now it will take 4.5 hours. In the previous one, it was taking 2 hours and about 19 minutes. So the printing time is highly dependent on the layer thickness. The Z value and the layer thickness will highly determine the printing time. And we have some parameters about interior, but it's better I make it horizontal again, or let's snap this one. Okay. Now our comparison will be much better. Yes. And let me show you the interior in this preview part. Let's go to top view. Yep, here we go. Now you can see the interior, how the printer is going to print your part. As you see, for the initial layers, it's printing the layers completely. They are filled 100%, but in the upcoming layers, we don't need to fill the interior completely. Instead, we have such triangular infill pattern. But again, it's up to you. You can decrease, let's say, wall count to wall thicknesses. If I make it 2, then there will be just 2 wall lines. As you see, here we have 2 of them. 2 wall lines, and this is an important parameter. It determines the thickness of your shell, and it highly affects the strength of your part. And then we have parameters about bottom thickness, top thickness. There are many of them, but I don't want to spend much time on it. I'm going to show you the infill. Here is the 20% of the interior is filled with material right now, but we can make it, let's say, 75. It will do the slicing and computation once again and show you the result. Yes, you see we have more triangles. This is how our printer is going to build it. But right now, I don't have any support structures. This is not marked as you see. And if you mark it, then it will generate some support structures according to the settings here. It will generate support structures everywhere by using the first extruder, first material. Now we can check it. I don't know whether yes, as you see, we don't have any support structure, right? Since we have a parameter here, we didn't discuss the details, but if I make it, let's say 45, let's see that it's going to generate any support structures. Again, we don't have, then I think it's taking the other angle. So let's make it 30. So you are the master, you can adjust all these settings and try to have the best printing case. But why it doesn't show the support structures? Okay, I will have a look at it later. Maybe in the layer view, it's not selected the support structures, but it's not a complicated case. And you may sometimes actually, I also printed this one without any support as far as I remember. So we can later come back to the support issue and I can show you more actually difficult cases which they really require support structures. And then you simply save it to a file, or if your printer is connected to your network, you can send it over Wi-Fi and don't need to transfer it manually.
Hojam, may I ask a question?
Sure.
For the infill density, is there any option for recommended density based on the material?
No recommendation, but if you start with the initial configuration, probably it will be around 20%, since you don't want to waste too much material if it's a kind of a toy-like shape. But if it's a mechanical part, if you're going to use it for, let's say, load carrying or load transmission, then it's better you increase the amount of material, you increase the number of shells, you may play with the infill pattern. So it's up to your case. You should know your design, you know your application, and then decide on the amount of material, amount of infill, and the type of infill. didn't show you a different one, but let's switch to a different infill. As you see, there are different ones. Let me make it concentric. And this one is using the offsets of the outer shell, for instance. It will be much stronger. Yes, you see, it's just using the offsets of the outer curves. And if you print it in this configuration, probably you will not be able to squeeze it. So if your application requires such a property, then you should switch to this one. Or these days, gyrate infill patterns are popular for mechanical parts. So let's see the result. So as you see, this one is a bit complicated, so it took much time. Now you'll see that it's changing the pattern. So it's quite difficult to see the 3D version of this one, but let's try. I can maybe make it X-ray, right? But I'm not sure whether we can see the interior. No. It's quite possible to see the layers in 3D, but in the gyroid part, in gyroid infill case, we have 3D shapes. You can easily visualize it by moving this cursor. The pattern, the interior pattern is changing. So we have 3D gyroid-like shapes, and this again increases the strength of the part. So the answer is fine. Is the answer fine, Mohammed? We have another
Yes,
one.
thank you.
You're welcome. Yes, the supports are mostly generated automatically, but you need to play with the parameters. Another question, the heating is up to you. If you look at the material here, the settings, the initial setting is 200 degrees for this material, and the build plate temperature, we'll talk about it later, that in FDM process, depending on the material, you need to heat this table so that your part will easily stick to the plate. If you don't heat, then you may have difficulties in keeping your part in position. There are also different ways. You may have some glue, you may use some tapes, but it's better if your printer has such a capability. It's better you increase the temperature of the bed and try to make sure that your part sticks to the table firmly. There's a question about surface quality. Yes, in the post-processing part, you can do some such manual grinding operations or chemical operations. We will discuss them in the upcoming chapters. There's another question about the layer thickness. Yes, in terms of quality, in terms of surface quality and part quality, it's better to decrease the layer thickness, but it will take lots of time. So again, depending on your time management, time problem, you may try to print in a shorter time with less quality, or in a longer time you can print, but the quality will be much better. Okay, I think we don't have much questions related to Cura. We can switch to the presentation.